Hello everyone. So in this video we will be studying about the behavioral design patterns. Let's see what all is there. So today we will see what are behavioral design patterns and what are the types of design patterns and some extras. I mean those are not in the slides, but I will tell you what to do with behavioral design patterns, when should you study about these patterns and why should you do that. Alright. So let's move on to the next slide and see what are behavioral design patterns. These patterns try to solve the problems by precisely assigning the responsibilities between the objects in a both decoupled and cohesive way. Alright, so what exactly does that mean? See, you define some abstractions that deal with relationships and responsibilities between the objects. So now there is a case where you want to measure and manage how and when two or more objects can communicate with each other by message passing or direct references as well. And many times you cannot merely obtain certain object references and call their methods, but you would like to use their functionality. And maybe also you may have diverse ways to define the behavior of an object, but you do not want to hard code many switch statements or draft the repetitive code. So that is the meaning of this first line. So in this way you are assigning the responsibility between the objects. In other words, these help us maintain the balance between those two concepts so that clients that interact with the objects won't have to know their internal connections. See, whenever you are using an object on the client side, you don't really want client to bother about what exactly is happening inside of an object. Okay, you just want that to have all the functionality that it wants, and definitely in order to do that you implement the behavioral design patterns. Now moving on to the types of behavioral design patterns. There are 10 types of behavioral design patterns. 10 types. Sounds too much, but anyway. The first is the strategy pattern, chain of responsibility pattern, command pattern, iterator pattern, mediator pattern, observer pattern, memento pattern, state pattern, template method pattern, and the visitor pattern. All of those have their different responsibilities, different use cases, but believe me, all of these are quite important when you are doing some real scalable software development. And you will understand why when you will build the projects. So we will also be building some projects using these design patterns in the upcoming videos, but first we will see the basics of these. Now I introduced you to the extra session, like what, when and why. So currently what we are doing is, this is the last type of design patterns that we are studying, the behavioral design patterns using the Typescript. And why we are doing it is because you do not simply want to build toy projects which are not really scalable and which do not really land you a job actually. So if you want to build something scalable, I mean you want to have a robust software in which you do not really need to make changes frequently, or you do not really want a messed up code. You want to be free of that so that you can think on a higher level. In order to achieve this, we are using these behavioral design patterns, and I mean any design pattern is used for that purpose only. Specifically these behavioral design patterns are for some complex level applications, since we said that there is responsibility between the objects, so you are having multiple objects that interact with the client. Now there should be some responsibility, and such kind of design pattern can only be in an application which is a bit complex. That is why we are doing this. So when should you do it is that if you are through with what are design patterns, if you are comfortable in Typescript language, or even if you are from any other programming language, that's okay, but you have a strong command of at least one programming language apart from PHP then you should study these kind of patterns. Alright, so that's it from the video. we studied about what are the behavioral design patterns and their types, and in the next videos we shall study about various types of these patterns one by one. So we will study about the strategy pattern and that observer pattern, memento pattern, visitor pattern, template method pattern, chain of responsibility pattern, and all and all. There are 10 patterns anyway. So stay tuned and do like the video and subscribe to the channel for getting the latest updates. Thank you. Hello everyone. So in this video, we will be covering all the behavioral design patterns. So first let's see this strategy pattern. Here we will see what is strategy pattern, the UML class diagram for it, implementation using Typescript, and at last into questions. So what is the strategy pattern? The strategy pattern represents a pattern that deals with encapsulating modified algorithms in an interface and making them interchangeable. This means you have an interface that represents a specific process or business case, and you interchange concrete implementations at runtime so that you can change its behavior. So let me explain. This pattern conceptually represents the simplest abstraction because it's essentially an interface that accepts different implementers at runtime. The only complexity you need to consider is how and when to switch between the strategies depending on the current context. Like there will be different classes where you will have your own algorithms that you will encapsulate, and between two different business logics you will be interchanging those algorithms that you have defined inside a class. So let's see the UML class diagram for it. As you can see, this is the UML class diagram. Here what we see is that the billing context is the object that the client uses to resolve strategies. This object will encapsulate the logic of switching the different objects via the common billing strategy. And now we need to implement two different concrete strategies that implement this interface for flexibility. Alright, so now we will be moving on to our IDE and write some code. Alright, so we are into our IDE. Now we will write an interface. Let's say interface strategy, and it has a method play. So play will return nothing. Simply write it as void. Now we will create a class strategy for Germany. Implements strategy, and let us implement this. Here what I will do is simply console log, and let's say we write some formation 4 3 3, and let's say substitution will be late. Usually Germany does that anyway. And strategy for Italy, so let's say class strategy for Italy implements strategy. Again implement this, and I'm gonna copy this, copy from here, and I will simply change this. So 4 2 3 and 2 1, 4 2 3 2 1, like this. Oh wait, did we make a mistake? Yeah, it should be 4 3 2 1 4 2 3 1 actually. So 6 3 9 and 4 2 3 2, like this. What we are going to do is that one only. we are now going to create one context. So class strategy context private strategy. So we encapsulated this, and let's say we have a constructor. You can do whatever you want. So here what I will do is I will remove this strategy because we will be creating a setter method. Let's say set strategy. So this will be void, and I will write this dot strategy equals to strategy like this, and play game. Play like this. Now as you can see what we did, we first created a strategy interface. It has two concrete implementations, and then we have a strategy context. Here this will allow you to set your own strategy. So in this way you can interchange the values on the client side. So what I will do is I will use this const strategy equals to new strategy context. This will take, okay, we don't have anything in constructor, we have to be strategy dot set strategy new strategy for Germany strategy dot play game. All right, so it should use the strategy for Germany. I will run this code. As you can see, 433 like this. Similarly, you can use strategy for Italy. If you run this, 4231 late. Like this it works. So this is how the coding of strategy pattern will work. Alright, so now we will move on to the interview questions of this design pattern. Here we are, the interview questions. First one, what are the main components of this pattern? Main components. So the main components are, first one is the strategy, second one is the context. The context maintains a reference to a strategy object and it is configured with a concrete strategy object. And the concrete strategy, the third one, implements the algorithm using the strategy interface. These three are the main components. What are some real world examples of this strategy pattern? So real world example is a navigation system that can provide different routes based on various strategies such as the fastest route, the shortest route, or the most scenic route. Each route calculation method can be encapsulated as a strategy and selected based on user preference. What are the benefits of using this pattern? Benefits are, first, it is flexible, so algorithms can be changed at runtime. Reusability is there, different strategies can be used interchangeably without altering the client code. And isolation of code means that each strategy is encapsulated in its own class, promoting cleaner code and separation of concerns. And also the ease of maintenance, this is quite maintainable pattern. What are the potential drawbacks of this pattern? So this has increased number of classes. So each strategy encapsulated in its own class, which can lead to proliferation of classes. Means, see that you had strategy for Germany, you also had strategy for Italy. Now there are 32 teams. You will create 32 different strategies. So in this way, this can become kind of difficult. And the complexity, the structure becomes more complex due to additional layer of strategy classes to the context class. Since you have one concrete implementation of a strategy, and then you have a context covering it. So let's say there is a different business logic in the same application where you might need to use a different context. So in such case, this can make it difficult to maintain. Alright, so these are the interview questions. That's it for the video, guys. Thank you for watching. Chain of responsibility pattern. So the same thing, the chain of responsibility pattern. Here we will see what is chain of responsibility pattern, UML diagram, implementation, and interview questions. So what is the chain of responsibility pattern? It is a pattern that allows you to have a list of classes perform certain operations on a particular object in a series of processing events. So let's say you have a list of classes and some certain operations, and that you are doing on a particular parameter you are passing or an object. So what you will do is, you will like dot handler and dot next and dot this dot that, like this you can do. This is the chain of responsibility, but I mean not directly, we will see while writing the code. So the main idea here is to establish a chain of handlers that take an object as a part of the request, perform some operation, and then pass on the object to the next handler. Exactly. So when you pass one parameter and you do one operation on that, that same parameter passed to the another handler which is chained into the previous one. That is how this pattern works. So one analogy of this pattern is that where, let's say, you have a group of friends and you pass along a message on a piece of paper. Each one of you has a chance to write something or change the message completely, and at the end of the chain you announce the final response. Alright, so let's see the UML class diagram for it. Here you can see the UML diagram, and let's see what is in there. Here the main class model is the request object. This is passed along the chain and gets transformed based on the handlers attached to that chain. Now we will need to attach the chain of handlers that will process this request. This is done by having an interface or abstract class request handler that each concrete handler will implement. So we see that both the concrete handler classes are chained together. One has a reference to the next one, and they are also both composites. You know about the composite pattern. So same thing here. And the client uses the root of the request handler chain, namely concrete handler A, and calls the handle method. This will subsequently call the handle method of concrete handler B before ending the chain of handlers. Okay, so now let us move on to our IDE and understand how to implement this using Typescript. Here we are in our IDE. So interface I request. So here what we'll write is get origin, and this will be string, and let's say get params, and this will be a map of string and string. We created our request interface. Now we will create the concrete implementation of that interface. Class http request implements iRequest. What we will do is we will have one constructor here. So constructor private origin string private params. map string and string. Here what we will do, return this dot origin and this will return the params. Alright. So this concrete HTTP request class represents the object that we pass along the chain of responsibility as a handler parameter. The actual chain is defined in the request handler interface. You will get these comments as well in the source code, don't worry. Now we will create an abstract class. Abstract class request handler constructor protected next request handler or null. So handle request I request, and if this dot next not equals to null, then this dot next dot handle request. So as long as we are passing the request object, this will continue to chain the methods. Now we shall have concrete implementation of this class. So class message handler extends request handler. Sorry. Okay, this does not have intelligence anyway. So handle request void and let's say log called inside the request.getOrigin, and if this dot next not equals to null, then the same thing, this dot next dot handle request. Now we will have the notification handler. Let's have some space here. I request. So I will do the same thing only. Here one thing, call inside the message by and call inside the notification by. Alright. Now we will use this on the client side. Let me explain you what all did we do. We create an interface, the I request interface, and it has these two methods. So it has one concrete implementation. This will be the object that will be passing to those handlers. Now we created an abstract class so that we can have multiple abstract implementations of this. We have message handler, we have notification handler. Here we are handling those, and you see this part. If this dot next not equals to null, this dot next dot handle request. So you will know how does this work. Okay. you will know how that this.next works on the client side. So const http req equals to new http request, and here what I will do, I will pass origin and the map. So let's say localhost, and there will be a map, new map dot set test val. Simple. Now new message handler, which will take new notification handler, and this will have nothing, null, simple. Dot handle http request, the request object which it is taking. Should we run this code? See, called inside the message by localhost, called inside the notification by localhost. So first is triggered. Here the notification handler sent to null, the notification handler class triggered. This message class triggered as well. Message handler request dot get origin. So we pass this origin. Origin was a local host, like this. Here we also see that if this dot next not equals to null, then this dot next dot handle request. So with this notification handler, you handle this, and when this went to the notification handler, it was null. So nothing happened. That is how this pattern works, guys. Alright. So now we will move on to the interview questions. Interview questions. What are the main components of this pattern? Main components are, first one is a handler, defines an interface for handling requests and optionally implements the link to the next handler. So we did not implement the link to the next handler, but yeah, it's optional. The concrete handler that implements the handler interface and handles the request. It may also pass the request to the next handler in the chain. So yeah, it does pass the request to the next handler. In the client side, it initiates the request and is not aware of which handler will handle it. What are some real world examples of this pattern? Real world example is, let's say, an issue escalation system in a customer support center. So a customer query might be first handled by a customer service representative. Now if the representative cannot resolve the issue, it can escalate it to the supervisor, and if the supervisor also cannot resolve it, it can further escalate it to the manager. So level by level we can escalate. I hope you don't have to face any escalation. Now what are the benefits of using this pattern? Talking about benefits, first it promotes the decoupling. The sender of a request is decoupled from its receiver, allowing multiple handlers to process the request independently. And the flexibility, the handlers can be added, removed, changed without affecting the client side, obviously. And the responsibility distribution, each handler only processes requests it is capable of handling, distributing responsibility across multiple handlers. Alright, so the fourth one, drawbacks. So the one drawback is that uncertain handling. It is not guaranteed that a request will be handled actually. So maybe it is passed through all the handlers without being processed. There are chances. And the difficulty in debugging also exists, because if you are going to trace the flow of requests, that can be, quite complex requests. So it can become quite difficult for you to debug because of the dynamic nature of this handler chain. So yeah, this is it from this design pattern. And the next that we are going to study is the command pattern. So yeah, thank you, and moving on to the next pattern. Now the iterator pattern. So iterator, it is an entity that is used to traverse a list of elements in a collection in an abstracted way. So what is the abstracted way? So let's say you want to traverse the elements in a direct way or a reverse order, or any kind of order you want to traverse, just that you don't really need to go deep inside of the element which is coming in every iteration. That is how you iterate in an abstracted way. So you can think of this pattern as an abstraction over for loops. The main idea is that you want to iterate over a data structure without knowing its inner details or how to access its elements in a particular order. So yeah, this is the definition of the iterator pattern. One analogy is that, let's say you have saved a list of favorite shows on your hard drive. So each of those videos are saved in a different folder, but you can definitely iterate over them one by one from here without knowing the details of their location in the disk, right? So you open the video application, you list all the videos, you don't know where they are stored, you just have those videos. That is the analogy. Now this UML class diagram, let's see how does this work. Here we start with the iterator interface, which exposes at minimum two methods. So one is the next method, another one is the has next method. So we want to provide a concrete implementation of the interface that implements the iteration process. So list node in the diagram is the underlying data structure that you want to traverse. Once you have defined these, you want to aggregate object that the client will use to retrieve the iterator for this collection. Here the linked list aggregate is the object the client will use to access the collection iterator. This object would also be good candidate for proxy and factory method as well, for sure, because those which we learned in the previous chapter, in those proxy pattern or the factory method, what happens is that in proxy you are creating one proxy so that with that class you will give access to another class, but in an encapsulated way or in a protected way, we can say. In the factory you are just creating the concrete implementation based on one interface, something like that. Now we will go to our IDE to implement this design pattern. I will create one interface, iterator, and let's have a generic T. So next, this will be returning the type T, and has next, definitely boolean. Now we have AI assisted development, so yeah, it is giving the suggestions. So let's create a list node class. This will not implement that interface, unlike what we have been doing till now, creating an interface and implementing it. This time something is different. So you might have seen linked list, so it is of that sort only. Public next list node T, and there will be a data. of type T. Constructor what we will do, this dot data equals data, this dot next equals to next. That's all you need to do in your linked list node class, not in the entire design pattern. Now I will create one iterator class list iterator T implements iterator T. अरे भाई implement करो. So this has implemented in a very strange way. I didn't mean to do this. Anyway, what I will do is I will create private root. From this root we will iterate always. So yeah, constructor root this or null, this dot root equals to root, and we have next method that returns T or null. So what we will do, we will have try catch block first in case any error comes. So return null. The next method, what error it is showing, man. This is anything. So if this dot has next fonts data equals to this dot root, which will surely exist, dot data, this dot root equals to this dot root dot next, again it will surely exist, return data like this, and has next return this dot root not equals to null like this. Anyway, so here what's happening is you are seeing one error and we'll fix it. Property next in type this is not assignable to the same property in base type. कुछ भी बोलता है कुछ भी. Alright, so we are going to fix this. It will take time. No. But I'm just showing you how to debug this. See, what happened is I renamed this to the iterator. Why? Because if I change it to iterator, iterator already exists somewhere. That's why I'm doing this. Now there's no issue, and what we will do, we will have one aggregate. So what is an aggregate here? You will know private root list. Again, this will have the list node type, and constructor cannot be written in this way. Anyway, get list iterator, list iterator, new list iterator, this dot root list. Aggregate is used to return the iterator. And one thing is that here you will pass the node of your choice. You will create one node with numbers or strings or whatever. So this will return the iterator in that way. Now we will be using this on our client side. Const list, creating a linked list, list node, new list node, new list node. Oh my god. Alright, here again we are having some errors. What errors are these? Argument in a parent list node. Any. Oh my man. Now how will I fix this error? Okay, let's move to this list node. Oh damn. This has to be here. Now the error is gone. Now what I will do, I will create one aggregate class object, new list aggregate, list. Again this aggregate. Now here, as I said, you created a list node with your integers and now pass that list, so you got the aggregate. How will you use that? You will get the iterator. Iterator equals to aggregate dot get list iterator. Now while iterator dot has next, console dot log iterator dot next. Damn, this is it. So now we will run this code. 20, 15, 10. 20, 15, 10. Why not 10, 15, 20? Because this is the first instantiation, this is the second instantiation, this is the third instantiation. Tongue twisters. That is why. So this is working really good, working really fine. Our iterator design pattern. Now let's move on to our interview questions. So the first one, what are the main components of this pattern? One is the iterator, an interface that defines method for accessing and traversing elements. One is the concrete iterator. So concrete iterator means the implementation of that iterator interface. Aggregate, which is a collection interface that defines method create an iterator object. And concrete aggregate means that class implementation. Real world examples are like, again, a TV remote control. But this time not passing the commands. So here you change the channels, Cartoon Network, and then Pogo, and then HBO, and then Star Cricket, Star Sports. Star Cricket is banned, yes. Nostalgia. Anyway, so like that, those TV channels you navigate through, and you don't know how they are managed internally. Have you ever thought like, where is this channel.png? Can I change it? No, right? But you are just watching that channel. So this is the example of this pattern. What are the benefits of using this? Benefit is that there is a kind of uniformity because it provides you a standard way to traverse different type of collections, and there is one encapsulation benefit as well. So internal structure remains hidden. I mean, you don't know what is happening internally. So also the solid principle, single responsibility principle it promotes and separates the responsibility of storing and traversing elements into different classes. And again, the extensibility it has, so new types of iterators can be added without changing the collection classes, like this. So here now we have potential drawbacks. Drawbacks is that performance overhead can appear because see, when the data is insanely large, and if you believe that other patterns can be useful, or maybe the data is insanely small, you don't really want to use this. So this is kind of like a middle class thing, used for middle only, like not too easy, not too tough. And then adding more and more iterator classes, you are iterating through a list, now you'll iterate through stack, iterate through queue, whatever, iterate through tree, like that. This can create a complexity. Anyway, this is it from the iterator pattern. We studied so many things about it. Now the next one is the mediator pattern. Right, so thank you. Now we'll see the mediator pattern. Bye. Now the command pattern. So this command pattern deals with creating the special request objects that can be passed as parameters to receiver objects. And the main idea of this pattern is that you want to separate a request action from handling each request in a way that both the request and receiver objects are decoupled. Let me explain this. So let's say you create an object that contains all the information necessary to perform actions such as triggering notifications or sending mails or whatever. Now this object will contain information such as the receiver's email address, name, and so on. So this receiver just knows how to process the commands and employs the appropriate handler depending on the type of the command. Getting it? So let's say a different example. So there is a microwave. You have microwave buttons that represent different actions. So when you press a button for warming your food, it starts warming. If you stop the microwave, there is a different command for that as well, like this. So we will see the UML class diagram for it now. This is the UML diagram. Here, as you can see, the commands represent the different actions that the receiver will accept, and the handler will accept the commands and delegate them to the receiver. We define a receiver object that exposes some methods. Instead of calling the receiver object directly, you create commands for each of its methods. So it is like turn on and turn off, or even you had commands, you type commands in the terminal, like that. So something of that sort. We will also need to define the handler that will delegate those commands to the on the behalf of the client. So the client uses this command handler and calls the handle method providing a command object. This way the client and receiver objects are decoupled from each other. Now we will be moving on to our IDE to implement this pattern. Okay, so I will create three interfaces actually. Interface command, so execute and nothing. I will be giving the simplest of examples, but thing is like these design patterns are really required for very complex level applications. So if you are concerned that why are we using simple examples, so this is just for your understanding. Going forward, we will also make projects based on these all the design patterns that we are studying. So don't worry about that. Interface command handler, to handle the command, basically handle command like this. What I will do, I will create this concrete implementation. So class concrete command A implements command. Let's implement this. So what I will be doing is I will also have to add the receiver as well. Who will receive these commands? Constructor private receiver that's it. So it is same as doing this dot receiver equals to receiver. It is same only. You can write either way. Method A. अरे ये क्या हो गया? Second implementation, I'll be doing the same thing. Method B. What I will do is I will have one handler. So to handle this command, but before handling the commands, see, you need to get all the commands, right? Private commands like this. Handle command dot execute, and this dot commands dot push command like this. Whatever command you pass, you are just pushing it into this array of commands. In this way, the handler will have all the commands that you are going to execute. Now what we will do is we will have concrete implementation of the receiver as well, the last class that we are going to create. Class a concrete receiver implements receiver, method A, method B. Array console.log receiver at method A, here it will be method B. Alright, now we will be using this at the client side. You had three interfaces: command, receiver, command handler. So for command you had two concrete implementations, so you just created these commands, and where your receiver is receiving commands, and you have a handler to handle these commands, and you are just adding this to your commands array. That is up to you. I mean, I just showed it for ease of use. So here we have a receiver as well that implements the receiver interface. So it has two methods. You can write anything. I mean, it is up to you what operation you want to. You want to return a string, or I mean literally whatever. That is not the main point here. The main point here is to know how this pattern works. So first we will create const handler new concrete command handler. Const receiver equals to new concrete receiver, and now let's handle your commands. Handler dot handle command new concrete command A receiver, handler dot handle command new concrete command B receiver. What will be the output? Can you guess it? Anyway, I will be running the code. Receiver at method A and receiver at method B. So the pattern is working successfully. That is how you can implement the command pattern using Typescript. So moving on to the interview questions. The interview questions: what are the main components of this design pattern? The main components: first is a command, second one is a concrete command. That concrete command, I mean, command is an interface and concrete command is the actual command that you are going to create, and then a receiver, and then there is a handler that will handle the command. You can also call it the invoker, and one the client side. These are the main components. Real world examples is a remote control. The very simple example I can give you is a remote control. You press the red button to turn off the TV and turn on it. Press the green button, I guess, to mute. I'm not sure, I haven't used TV for 10 years. Anyway, like that. What are the benefits of using this pattern? Yeah, every pattern has benefits and drawbacks as well. Anyway, benefits is that, again, this promotes the decoupling. The sender of request decoupled from the receiver. Definitely, sender is different, receiver is different. No connection. Extensibility. New commands can be added without changing existing code. This is one of the great advantages of this pattern. New commands can be added. Anyway, undo, redo. Commands can be stored, allowing for undo and redo functionality. So, see, this might sound strange. You might have created one rich text editor. So, there you can utilize this. Now, what are the potential drawbacks? Drawbacks is increased complexity, means again you need to increase the number of classes. You cannot simply play with the methods. There have to be different classes, different commands. Also, one overhead is that memory. So you are storing the commands. So for storing the commands in an array, let's say you have 100 commands. So this will definitely increase the space complexity. Anyway, so these are the interview questions, and the next one that we are going to study will be the Iterator pattern. Thank you so much. And now the mediator pattern. So the mediator represents an object that acts as a delegator between multiple services, and its main job is to simplify the communication between them. Alright, so let's say there is class 1 and class 2. So you will create one different class, a mediator class, so that you can communicate between those two classes, so that if you want to use the methods of both of them, then you will have a mediator that utilizes those two, so that your communication between those two classes is simplified. This means it tries to encapsulate their complexities behind a simple interface, so that you can change an implementation details without changing the client that uses the mediator. So here what happens is that you will not need to make changes on the client side. Basically, you will only need to make changes inside the mediator or the classes that you are using for mediation. Okay, so let's move on to this UML class diagram. Sorry. So in this UML class diagram, we see that first is this mediator interface, which consists of a series of methods that bridge some functionality between the other objects as shown here. Now, when you define the interface for mediator, you will need to create one concrete implementation. One concrete implementation that will aggregate all the objects that you want to depend on. So aggregate all the objects that you want to depend on means that for all the objects, means the classes that you are creating, all of those will work inside that mediator. So let's say, for example, if you do not want to directly call the batch worker class from the single task worker class, or vice versa, instead use the mediator, which is set by the common workhorse abstract class that both single task worker and batch worker inherit from. So the mediator object will be responsible for triggering different methods or events to either single task worker or the batch worker. Alright, so now we will be moving on to our IDE to implement this. I will create one interface worker mediator, and there will be trigger event. So there will be a sender object. This will be a simple object. Message will be a string, and this will return nothing. I mean, you can return anything of your choice. And now we just want to see some simple implementation. Now we will create one class worker center implements worker mediator. Let's implement this. You can see different, just for optional. So I will just remove this, and what I will do, let's also add one public access modifier just for readability. And here I will create one constructor actually, and this will have two parameters: protected worker A. This will be batch worker. This class we will create, and protected worker B single task worker. This class will also create. Alright, what I will do is this dot worker A dot set mediator, this dot worker B dot set mediator, this. Anyway, and now in this trigger event, what I'll do, if message dot starts with, okay, I have to set this as a string, and here it will be object message dot starts with single job completed. then this dot worker A dot finalize. Actually this is taking intelligence from one other file, maybe where we have also defined the mediator, but anyway, if message dot starts with batch job completed, this dot worker B dot perform work, this I will do. Okay, now here you can see one error, duplicate identifier. This was also declared here. We will be fixing it very soon, don't worry. So I will create an abstract class here. I will have the mediator. Worker mediator, or maybe it is undefined. Constructor mediator, and it is completely optional. This dot mediator equals to mediator. Set mediator worker mediator, and this will return void. This dot mediator equals to mediator, like this, just a setter method. Won't be having getter, just abstract class. Now I will create my batch worker and the single task worker class, after which we will be done. So class batch worker extends workers. So what I will do, public perform work void console.log performing work in batch worker, just to make sure that we are inside the batch worker. And if this dot mediator, so if mediator is there, trigger event, we will trigger this event. This will be the object, so the object we are passing, and final job completed. No, sorry, batch job completed. And one finalize method as well. So I will be copying this. Here will be our finalize, and here it will be final job completed. So when the batch job stops, basically. Now will be the single task worker. Extends workhorse. Okay, workhorse. Here H will be capital, and here we are getting one error, duplicate as same thing. I will fix this very soon. I will show you how. So in this single task worker, you have the perform work method. You don't have finalize because this is only doing the single task. So single task worker, I will copy this simply, and here added some conditions. Yeah, single job completed. Alright guys, so now we will be fixing that error. So here what you will do is you will open your tsconfig.json and add this in the exclude. For now I am doing this. Okay, let's do this comma. So you see that error is gone. It is not checking multiple files no longer. Now we will be using this on the client side. Const worker A equals to new batch worker. Const worker B will be new single task worker. And the mediator equals to new worker center, worker A, worker B. Now worker A dot perform work. Now you will see the magic. So before running this code, I will tell you what's happening here. First we will create a mediator interface and then the concrete implementation of it. Here it will have a trigger event method which is calling the methods of both the workers based on the messages that we are sending. Now here you have an abstract class. So this abstract class we just simply created to maintain a kind of uniformity amongst all the other child classes that will be used for mediation. I mean you don't really need to do that. So this perform work in the batch work, and here we are triggering this event, batch job completed. So trigger event will go straight to here. Here the message is this, and this will do the perform work. Apart from that, this will be the finalized. So final job complete means the final task, but here we are having the single job completed. So there is a batch job in which all those single tasks are happening. So this way, see, this is triggering this event, the worker B is single task worker. You see guys, from this batch job you are communicating through worker B, which is the single task worker. I will add comment. That is how you mediate between the two classes using the mediator pattern. Now we will run this code. As you can see, performing work in batch worker, performing work in single task worker, and performing work in batch worker for finalize. It went into the batch, performed a single task, and then finally it completed its job. That is how the mediator pattern works inside Typescript. That's the implementation. Now we will be moving on to the interview questions. So this is the observer pattern. Observer is a design pattern that establishes a subscription model of communication. In other words, you use a publisher object that posts messages to a list of active subscribers in regard to some events that occur or when a specific rule is activated. Those rules could be some points of interest. So let me explain. Let's say you want to send notifications after a user has registered or some part of your application needs to get an update from a different part of an application. So this way you will establish a one-to-many communication model between the publisher and the subscriber list. So the publisher would not know in this case what the subscriber list look like. It only allows a reference to an interface that can push messages into it. And on the other side as well, the subscriber will receive events from the publisher that it subscribes to and has the choice of acting on or disregarding them. If the publisher somehow gets destroyed, subsequently, it will also remove any references to the subscriber list. So the subscriber will also be lost if it's not used anywhere. That's why in order to create one-to-many communication between the objects, we use the observer pattern, and In order to trigger events to different parts of an application without coupling dependencies, we use this observer pattern. Alright guys, so now moving on to the UML class diagram. In this, you can see that subject represents the object that holds the state of the application and notifies the subscribers of any updates of this state. So the subscriber represents the observer object here. Okay. Once again I am saying subscriber represents the observer object that listens to events from subject. The shared state property is retrieved by the subscriber object once it is notified by the subject. So the subject object also has the ability to add or remove subscribers on the fly. This is to ensure the dynamic nature of the list and to ensure accurate message passing. Alright, this is the UML class diagram explanation. Now we will move on to our IDE to write some code and how to implement this design pattern using Typescript. I will create one interface and name it observer for easy understanding. So update method, there will be a subject. We have not created it, we will create. Now there will be interface subject. Here let's say attach observer void detach observer void notify literally nothing void. Anyway, now you will have one concrete implementation of that subject. I will create one state property. Since the state was shared, I am making this public. Currently setting it to simple number. You can set it to whatever you want. And observers. So this obviously you don't want to share. So that's why. Public attach. I have an attach method. Observer is the param. Now let's check for the existence. Equals to observers dot includes observer. We are checking whether the observer exists. If it does, we simply return the log statement that already attached the observer. Here the log as well returns void, so that's why we are doing this. Otherwise, attached and observer to log this dot observers dot push observer like this. You will have detach method as well, and you will have notify method. So this is the way you are attaching an observer. Now you will detach. Let's say index equals to this, and if index, let's say it is -1, what we will do, we will simply return this log statement, console log this observer does not exist, else we will detach this splice method and will log successfully detached an observer. You can take this analogy as subscribing, unsubscribing and all. Now comes the notify. So we are notifying the observers. We have a for loop here for let observer of observers observer dot update what? Passing this object. You see this observer method. On line number 1 you see interface, and line number 2 you see the update method. So now, since you are updating it, how exactly you are using that update? So we will have a concrete observer as well. Concrete observer implements observer. Let's implement this. So observer reacted to the event. Anyway, this is all the coding part, and I mean we don't really need to do any logging or using on the client side. Basically what we are doing is, let me tell you, you might have worked with intersection observer API as well, that interacts between your mouse event and on the page. So one is the class mouse, which handles the interaction of the mouse, and the one is the page. So where is the page going? As soon as the interaction happens, you do your operations. In the same way, here you create an observer, and there is a subject which will be observed. So this is being observed by the observer, and you have your own methods. So observer is attached, now it is observing it. It is detached, so observer is now detached, so it is no longer observing it. And then you have a notify method. That's the whole implementation, means the coding part of the observer design pattern using Typescript. Now we will move on to the interview questions. Alright, so what are the main components of this pattern? So main components are subject and the concrete implementation of the subject, observer and interface, or an abstract class. Maybe you can also have an abstract class as an observer, not necessarily an interface, that defines an update method which is called when the subject state changes, and the concrete observer means the implementation of that observer. Basically two classes, one is the concrete subject and another is the concrete observer. What are some real world examples of this pattern? A real world example of the observer pattern is a newspaper subscription service. So let's say you have subscribed to a newspaper, okay. So when the new edition of the newspaper published, you are notified that a new kind of newspaper will come. Also, the publisher doesn't need to know about the subscriber directly. I mean, it just publishes the new edition and all of its subscribers are automatically notified. This is the real world example. Benefits, again, the loose coupling means that observers are loosely coupled. Subject doesn't need to know the details of the observers. Definitely. Dynamic relationship means observer can be added or removed at runtime, allowing for flexible and dynamic relationships. And scalability supports this pattern supports the addition of any number of observers, making scalable for systems that need to notify multiple objects about changes. Now, the drawbacks. One major drawback is that memory leak. If observers are not removed properly, it can lead to memory leaks due to lingering references. So, see, you have a lot of observers in an array. Now, you have attach method, but you are now detaching those observers when not needed, then there will be a lot of memory leak because of this. Now, again, one more drawback is that notification overhead. Frequent state changes in the subject can result in high volume of notifications. So since there will be high volume of notifications, you are informing all your subscribers anyway. So you will have to, keep check on the performance and add some additional lines of code to improve the performance. Alright, so these are the drawbacks, and yeah, that is it about the observer pattern. And the next one is the Memento pattern. So yeah, meet you in the Memento pattern part. Thank you. Memento pattern. So this pattern deals with saving and restoring an object's state across parts of the application without exposing any implementation details. So see, you might have worked with Redux, or in Angular you might have worked with RxJS, or state management libraries, MobX and all. Internally you don't need to know what they are doing. They are just saving your state, and you can also restore your state, reset it. So it is like global state management. You can think of it as a state management pattern that offers a simple way of storing data in a repository, and then when needed restores the previous data on demand. Obviously, so here one catch is that you persist the previous state and you keep the new state or the current state as well inside that persistent variable. That is how the Memento pattern works. So let's see a UML class diagram to understand it further. This is the UML class diagram for it. Here you can see the app state interface represents the state object that you want to save or restore. Alright, and the originator class holds this state to perform work and updates it when required. It will also call the save method, which will return a memento object. As you can see, the save method in the originator, and this will return the memento object itself. Also, this object is of no use to the originator. You need a caretaker class that will aggregate all those memento objects. Like, you can think of it as a storage object. Think of caretaker as a storage object. You see mementos, array of mementos you can see. Likewise, it works. Hence, when a user wants to restore a previous memento, they will use the restore last memento method, which will update the caretaker state directly. That is how the UML class diagram for Memento pattern has been built. Now let's move on to our IDE to implement this pattern using Typescript. I'll create one interface, app state, and let's say you have some data. It can be of any type. Okay, currently I'm using any because you can literally store anything. So anyway, the comment was not needed. Now I will have an abstract class memento. State app state. So here we are just initializing our state, and now let's have a getter method, return this dot state. Now we will have a concrete implementation of this memento. Here what we will do is get state super.getState. What did I do just now? Super.getState. So yeah, I mean the super is coming from this constructor, and likewise when you will initialize this, all the properties from the abstract class will come here. Now I will create one originator. Class originator. Here the state will be private. There it was protected. Abstract class protected. Now constructor. Again this dot state equals to state, and now we have a save method that will return the memento like this, and one restore method that will take the memento as a parameter, but it will return nothing. What I'll do, this dot state equals memento dot get state, like this. So you are restoring the state. You might have some previous state, let's say variable increased from 2 to 3, but you want to get 2, so you restore it. Now we will have a caretaker object. Class caretaker, private originator, memento. So let's have a constructor. Originator and mementos. This will be optional basically. Memento. What I'll do, originator, and if we have mementos, this dot mementos, alright, restore last memento. So last save we are going to restore. If this dot mementos dot length triple equals to 0, what you will do, return nothing. Otherwise const memento equals to this dot mementos dot hop. Here what we did, okay, we have an error. Alright. I will add this. This will certainly exist. So you are popping up the current memento and restoring it inside the originator. Now you have save memento method. Push originator dot save. So here you just see we are also saving inside the originator, instantiating this concrete memento, and we are also pushing the memento into this array of mementos. Alright, now I will use this pattern on the client side. Before using it, let me explain what I did. So we created an app state. You can set it literally anything. I mean, it's up to you. Data we set to any. You can set a string array or whatever. You can add static typing if it really means everything for you. And abstract class you create memento, which is responsible for creating the concrete memento. This is a very small class that we created. You can add your own methods. Now you can also add your constructors as well. And you have an originator from where you have the save and restore methods, and then you also initialize a concrete memento with that particular state, just in order to save all the states that you are having so that you can restore. Now here you have a caretaker, which is more like a storage object. So this storage object has an array of mementos and an originator for doing the operations. So this originator is doing the operations here for restoring and saving. Next, now I will create a variable called state app state here. Now see, property data is missing. I know, bro. So data I am passing as, let's say user details. What I will do, I will have the originator, new originator state. So this originator is now taking the state, and caretaker originator. We are not passing the array of mementos, so you can do it if you want. So we will do first a console log originator data originator dot save dot get state dot data. First you are saving the state and getting that state, and inside that state whatever you have you are retrieving. Now you just change the state to user, let's say info, caretaker dot save memento. Now caretaker dot restore last memento. Here you will see the magic happen. Console log restore data originator dot save dot get state dot data, like this. Gonna run this code. Alright, so here we have an error. Cannot read properties of undefined, reading push. So yeah, here it is showing this error because our memento is undefined. So I will be fixing this error here. Anyway, I will run this. You see, here it is. So originator data, you have the user details. Now you change the state, save the memento, and then what you did is you are viewing the restored data, is the user info. So restoring means that the current state that you have set will be restored always. Alright, that's how it works. This is all the TypeScript implementation of this Memento pattern. Now we'll move on to the interview questions. The interview questions: what are the main components of this pattern? So first one is the state interface that you had, and the second one is the originator that will maintain the saving and restoring. Third one is the memento object itself, so the abstract class memento and then its concrete implementation. And then the caretaker object, which will work as a storage object. So these are the main components. Now, what are some real world examples of this pattern? So the real world examples are like, you might have worked with state management libraries. Basically you might have worked with Redux, so you might have worked with Zustand as well, and yeah these kind of things if you have used, then you are very well aware about the real world examples of this pattern. Apart from that, another more realistic example is that text editor with the undo functionality. So user makes changes and editor saves the state of the document. Now if the user decides to undo the changes, you can restore the document to its previous state using the save movement. Alright, now what are the benefits of using this pattern? So benefit, first of all, encapsulation. It preserves the encapsulation boundaries by not exposing internal state of originator to the other objects. So your state is completely private. You see, in the originator object we have private state, so in that way it helps in encapsulation. Apart from that, it is beneficial for the state management as well. Talking about the drawbacks or limitations. So first is the memory overhead, since storing mementos can be memory insensitive if the object state is large or many mementos are stored as well. And the second one is the serialization issues. So if the memento involves complex state, it can be challenging to serialize or deserialize it correctly. Alright, so these were the interview questions, and this is all about the memento pattern. The next one is the state pattern. Right, so yeah, let's meet in the state pattern. State pattern. So this state pattern deals with the state management concerning a particular object and how to make an object behave differently based on its inner state. So let's say you have an object in which you are maintaining a state. So what you will do is you will want that object to behave differently according to different kind of situations that are provided by the client side. So in this case, you will be using an object that will be responsible for the state management of your application. Here you have an object similar to the originator object from the memento pattern. Then at runtime you change its internal state and the object will behave differently when used by the client. So we can think of this pattern like having a state machine that changes the behavior of an object when its internal state changes. So when you will be placing the logic statements based on object state parameter, it is useful if you want to implement inheritance without actually defining subclass. Like that. Alright, so let's move on to the UML class diagram for this. This is the UML class diagram for the state pattern. Here, as you can see, the originator owns a single state object which can have many forms. So the state can have many forms: active state, passive state, or whatever state. And we can use either the subclassing or a factory method pattern here to have different variations of the state interface. Then call the change state method that assigns a different state object to the originator, after which the originator will behave according to its current state. This is the UML class diagram. Now we will be moving on to our IDE to implement this pattern using Typescript. I'll create an interface state on enter state, let's say, void report state void. Quite simple. So we have now two concrete implementations: class active state implement state and class passive state implement state. Like this. What I'll do, I will have a data parameter, data field basically, not parameter, sorry. Data can be of any type. I am putting any, you can put any kind of state that you want to keep here. Constructor, and here I am just not taking any parameter. Active state, so I'm setting a string, or let's say active data, not a string. Here on the report state, what I will do, originator change to active mode, and here what I will do, okay, here this is the report state basically, so is in, and here alright. Now the same thing with the passive state, just some value differences. Like that. Alright, now I will create an originator. Private state. So as you all know that originator encapsulates your state. Constructor, and here instead of taking the state as the parameter, I will initially set it to the passive state. Okay, now I will have a change state method. So this dot state equals to state, and this dot state dot on enter state. So when you are changing the state, this will call this on enter state method. So on enter state, originator change into passive mode or originator change into active mode. Now the report state, this dot state dot report state, like this, and this is optional, but anyway you can have it. What we did is we created a state interface, and we have different type of concrete implementations of that state, so where you can keep your data, which is the inner part of your state, and based on this data your application will behave differently. So here we are simply having the any type. You can set the string type or whatever you want. Here you have on enter state and report state methods, so that you can know currently in which state your originator is, and then your originator which is managing all those states. Alright, now I will be using this on the client side. Const originator equals to new originator. Originator dot report state. Now originator dot change state new active state. Now again originator dot report state. What will happen? I will be running this code. Let's run this code. As you can see, initially it was in passive state, so originator is in passive mode. When you change the state, so originator change into active mode, and then originator is in active mode. So our state pattern implementation is quite working. And now we will be moving on to the interview questions. Alright. So what are the main components of this pattern? So the main components of state pattern are, first is the state interface, and second is its concrete implementations. So third one is the originator that manages all those states. These are the three components of this state pattern. Alright. Moving on to the another question, real world examples. So real world examples is like a traffic light system. So it can be in various states: green state, yellow state, red state. So the behavior of traffic light changes depending on its current state. Now, what are the benefits of using this pattern? So simplified state transitions is the first benefit, because it encapsulates state specific behavior. And the other benefit is, solid principles. From the solid principles, single responsibility principle. So each state is responsible for its behavior, leading to better organized and more maintainable code. And another one is the open close principle. So new states can be added while modifying existing state classes. What are the potential drawbacks of this pattern? So drawbacks is like, first, the increased number of classes. For different states you will have different classes, and this will make it complex, and the initial setup requires kind of boilerplate code. These are the only drawbacks. I mean, these do not really affect much, but anyway, these are. So yeah, this is it about the state pattern. Next we will know about the template method pattern. Alright, so meeting you in the template method pattern. Bye. The template method pattern. So this pattern is used to define a basic template of an algorithm and have subclasses override specific steps at runtime. Let's say you have a particular algorithm for a particular feature inside your product, but what you will do is you will first define a basic template, so that this is the basic behavior of that feature. But at times you will need to have different kind of behaviors for that feature, so you will create subclasses for that, and then those subclasses will use the same template of that feature, so that at runtime you can override specific steps, like at some point you are giving coupons, at some point you are not, like that. So this means you have a series of steps in an algorithm, but you want to consider having a placeholder call that delegates the logic to subclasses. So there can be multiple placeholder calls basically, so that here what you will do, that placeholder call will be responsible for like delegating the logic to subclasses, means those subclasses will have the logic provided by this placeholder call. Alright, so let's look into the UML class diagram for this. This is the UML class diagram for template method pattern. Here what we are doing is the base class, which is the shipping items template, and a class that defines some common steps to ship items through a carrier has a prepare items method which is common across. So, and this does not change. But subclasses need to implement perform shipment method which sends the items through the carrier. So the two implementations for AR and LAN shipments inherit from the base class and implement the correct method. There is also an optional method called onItemShipped, which is a life cycle method basically that is called after the call to the perform shipment method. So when the perform shipment method is called, then this onItemShipped will be called. And yeah, the classes may implement this to perform optional tasks, but by default this method is not implemented. Alright, so this is about the UML class diagram. Now let's move on to our IDE to see the implementation of this using Typescript. I will create an abstract class. Shipping items template, ship items. Items will be, array of string. Won't return anything. So I will have some methods first before defining the ship items. So I will have protected prepare items, and here I will simply log to show that this is being prepared. Okay, there's a typo actually. Now abstract. Now this method is abstract because we do need to implement this. And protected on items shipped. Being shipped, or rather like this. Now we will have the concrete implementations. So there will be subclasses basically, one for air shipment, another for land shipment. So class air shipment extends this, and I press control dot, in the perform shipment, what are you going to do is that like this, nothing so fancy. And the on item shipped. Okay. Likewise, we will have the land shipment. Land shipment. Like this. So what we did is we created one abstract class which is the template for all the features. Okay, wait, I forgot to implement this. So this dot prepare items, first we will prepare this dot perform shipment, and this dot on item shipped, like this. Anyway, we created a template, and here we defined our methods. You can define your own methods. And we created these two, we can call these two scenarios. You can ship air items, you can ship land items. So these two are the scenarios that are following this template. And now on the client side, when you are using it, what you will do, const air shipment of type shipping items template equals to new air shipment, like this. So what I will do is air shipment dot ship items fighter jets, let's say, or UAV unmanned air vehicles, land shipment dot ship items armored tanks, assault rifles, like this. I'm gonna run this code and see fighter jets is being prepared, UAV is being prepared, 2 air items being shipped successfully, and then this is being prepared, this, that. This is the pattern that is working fine, and we implement this using Typescript. I hope you got full explanation and understanding of this pattern. And now moving on to the interview questions. Alright, so the interview questions. What are the main components of this pattern? The main components of this pattern, first is that abstract class, means the template that you had. The second one is your template methods, or your concrete implementations. So first is the template method and then the concrete implementation, basically. Sorry, my bad. So in an abstract class you had the template method, the perform shipment method. So that was your template method which was required, and then the concrete classes. So these are the only 3 components. Real world examples is like a data processing framework, let's say. So a framework that defines a template that includes such steps, like reading data or processing data, saving data, and subclasses can override specific steps to provide custom implementations for reading, processing, and saving different types of data. That is the real world example. What are the benefits of using this pattern? So benefits is like code reusability or flexibility, and the consistent algorithmic structure, means that the overall structure of algorithm remains consistent. And the drawbacks, so this has one inheritance limitation. So this pattern relies on inheritance. So inheritance can limit the flexibility sometimes, and this can lead to tight coupling. And code maintenance means changes to the algorithmic structure in the base class can affect all the subclasses. So these are the drawbacks. Now we will be moving on to the last behavioral design pattern, which is the visitor pattern. So meet you in the visitor pattern. Bye. Alright, finally the last pattern, the visitor pattern. So let's see what visitor pattern is. This pattern deals with applying the customized behavior to an existing list of components that form a hierarchy, maybe a tree, binary tree, binary search tree, or a linked list, but without changing their structure or having them implement an interface. What does it mean? So this means that you make your components have a method that accepts a reference of a visitor object. Okay, and then it passes its own instance as a parameter to this visitor. And the visitor, on the other hand, will have access to each type of visited object's public methods, and they can aggregate the state of each object it visits into a different result. You use this pattern mostly when you want to abstract some functionality for collecting the public state of a hierarchy of objects, or maybe you want to apply one or more new operations to a group of objects that share the same interface but have concrete subclasses. Alright, so let's move on to the UML class diagram for this. So this is the UML class diagram for the visitor pattern. Here we have a basic interface of accepts visitor, which requires a single method for accepting a visitor object. Then we have the document visitor interface, which defines the methods for the actual visitor class. We also have concrete implementations of both of these, plus the implementation of the composite pattern as well. So we have already studied about the composite pattern. The logic of this diagram goes as like, concrete document visitor knows how to accept and use the special concrete document A and concrete document B subclasses because it accepts them as parameters. And on the composite document side, you have a single accept method that iterates over the private instances of the accept visitor interface and calls this method on each of them. This will trigger the polymorphic calls to the pass visitor instance parameter. Alright, so now let's move on to our IDE to implement this pattern. I will create one interface document visitor, visit PDF doc, let's say PDF will have PDF doc. We have not defined it yet, but we will do. And visit Word doc. So I will also have an interface called as accepts visitor, which will accept should have the accept method, and here what you will do, this will have the document visitor type. So this will accept a parameter visitor of type document visitor. Now let's have our concrete implementation of accepts visitor. So class PDF doc implements accepts visitor, and let's implement this. Class Word doc implements accepts visitor and accepts. What you will do here is visitor dot visit PDF doc, and you will pass this object. Same thing, visitor dot visit Word doc, passing this object. I will also have one public method. So public view method. So you just want to view your PDF. Viewing the PDF, and you can also have this method here in the Word doc class, viewing the Word document. And since you can also edit the Word document, you can have edit method as well, console.log editing the Word document, like this. Now what I will do, I will have the implementation of the document visitor interface. Here what I will do, I will have pdf dot view, and here I will have docs dot edit. So you can have your own methods, you can have your own operations. I am just doing view and edit. Now I will have one composite class. Composite document implements accepts visitor, and here we have an accept method, but before that what I will do, I will have array of documents. Like this. I will also have add document, this will return nothing, and dot push d, like this. So in this accept, what we will do, we will run a for loop const doc of visitor, or sorry, not of visitor actually, doc of documents, doc dot accept visitor, and now I will be using this on the client side. Equals to new composite document. First we will instantiate the composite class, const visitor equals to new document visitor implementation, composite dot add document, new pdf doc, and dot composite dot add document, new word doc. After this I will have accept method composite dot accept the visitor, someone that visits the documents. I will be running this code. So yeah, viewing the PDF, editing the Word document, like this. So the visitor visited all the documents and then did the operations that you wanted here. Alright, so this is how the visitor pattern works in TypeScript. Now let's move on to the interview questions. What are the main components of this pattern? Main component first is a visitor, which is an interface or maybe an abstract class that declares visit methods for each type of document or maybe each type of element in the object structure, and its concrete implementation. And there is an element which is an interface or an abstract class that declares an accept method which takes a visitor as an argument, and then the concrete implementation of this element. Apart from that, we have an object structure, a class or maybe a collection that can enumerate its elements and allow a visitor to visit them. So you already saw we had an array of documents. That is what we call the object structure. Real world examples. Real world examples is a tax calculation system, in that different types of products like books, electronics, food may have different tax rules. So instead of implementing a tax calculation logic within each product class, a visitor can be created to encapsulate the tax calculation logic. The products accept the visitor, which then applies the appropriate tax calculation. Benefits of using this pattern are, separation of concerns. So it separates the algorithm, means the visitor, from the object structure, means that array of documents we have, making it easier to manage and extend both independently. It follows the open-close principle from the solid principles. And how does it follows it? Means new operations can be added by creating new visitors without changing the existing object structure. And then the simplified maintenance means the modifications to operations are localized to visitor classes, reducing the risk of unintended side effects. Alright guys, so this is the benefits. I forgot that this is one more into question. Anyway, potential drawbacks. Drawbacks is that it has a tight coupling. So with the tight coupling between the visitor and its elements, especially if the element interface is not carefully designed, this can lead to a bit of complexity, and this can also lead to maintenance overhead. Finally, we completed our interview questions as well for this visitor pattern, and all the behavioral design patterns are now completed, so that you can always view this in the particular timestamp. I will be providing the timestamp in this video. In case if you have any doubt, please leave a comment with that timestamp so that I will definitely clear your doubt. I will be clearing your doubt and I will give proper explanation. And please do like this video and consider subscribing the channel. It takes really hard work to do this. Alright guys, thank you so much for watching this video. Thank you very much, and see you in the next video. Bye.